Responsiveness, how you respond to something. So a measure of a consumer's responsiveness. RESPONSIVENESS. Responsiveness to a change in price. So what this really tries to answer is, will a change in price have no, little, or a huge impact on what you buy? Will a change in price have no, little, or a huge impact on what you buy? And we talked a little bit on Friday about medicine versus Coke, and we talked about medicine is like the rock because a change in price isn't going to really change how much people buy. They still need the medicine, whether it's expensive or not. But if you look at something like Coke, if it gets really expensive, people might switch to Pepsi, or they might go to no name, or they might buy something different. They might choose to drink water. So there's a big change in the Coke as opposed to the medicine. What we're comparing is price and demand. So demand is you, the consumer, and that's why I wanted to highlight those words. At the end of this unit, what's going to happen is these are all going to sound the same because they all have their little acronym and they all have the word elasticity in them. So by highlighting price and demand, you understand we're comparing those two things. Each one of the four we're going to look at have their own formula. So that's why I'm giving you the fancy yellow card. We're going to write all the formulas on the card so you don't have to keep flipping through all the notes to find them. So the front of the card, I want you to split it in half vertically. So draw a line down the middle, the same on the back. So draw a vertical line down the middle. Okay, and a vertical line on the back, so then we have 4 spaces to put each of these formulas. At the top of one of those 4 sections, doesn't matter, you're going to write price, elasticity, or demand. If you can remember the acronym PED, then write that instead, so whatever makes more sense for you. It doesn't have to be perfect, Quinn. But you can't see through the paper. Okay, I got it. Left-brained. That's very left-brained. Okay, so PED, P for price, D for demand. Okay, formula is negative % change in quantity demanded divided by the percentage change in price. There it is in words. I'm going to give it to you in a shortened version, and then I'll give you with symbols. Now, there's actually 2 ways to do this, and the book does it one way, and I do it a different way, so I want to explain. This is the way the book gives the formula. They put a negative in front. And the reason they have to put a negative is because the slope of demand is negative. So you need a negative to balance a negative, because a negative and a negative is a positive. That's why they throw a negative. I do absolute value. So I throw absolute value around the top, so whether the answer on the top is negative or positive, it always turns positive. So you can put the negative, or you can put the absolute value symbol. It's completely up to you, but you can't use both. So I'm just going to bracket the negative. That's the way you'll see it in the book. Because I'm a mathematician, I just have to use absolute value. I don't know why. It just looks better. Do you understand those two? Okay, so completely up to you. So negative equals positive, or absolute value equals positive. Just 2 different ways to express a positive number. Book likes the negative, I like the absolute value. It does make a yes. Yeah, because we don't like double negatives in English. We're like, oh. I always say, I don't eat no bananas. What does that mean? Yeah, that's why negative times a negative is a positive. Same thing in English. Okay, so I'm going to write this in a shorter version, and then I'm going to write it as a formula with variables, completely up to you which way your brain memorizes it. If you're more right brain, you might like the words. If you're more left brain, you might like the formula with variables. So on the top, what this means, a percentage change in the quantity demanded is we take whatever the new QD is, and that will be given in the question. They'll tell you after the price change how many people are going to buy. We're going to subtract the old QD. Again, will be given in the question. To get a percentage, we have to divide by something, and we have to times by 100. What we're dividing by is the old QD. So that's the top of the formula. It's the new QD minus the old QD, divide by old QD times 100 is the percentage change in the quantity demanded. Again, I absolute value the entire top. Book puts a negative. Either way, it's going to end up positive, however your brain wants to remember that. Then the bottom formula is a percentage change in price. So we take the new price minus the old price, divide by, follow the top, old price times 100. All of that will come down to a number, and I'll tell you in a second what the number means. Now, this is where economists really need to be mathematicians, because as a mathematician, if you're multiplying by 100 on the top and you're multiplying by 100 on the bottom, do you really need to do that step? The formula has it in. As a mathematician, I never do this because you know it's going to cancel each other out. Your brain might like the words. Your brain might like the shortened version. Your brain might like this. We call it Q2 minus Q1 in absolute value, divide by Q1, divided by P2 minus P1 divided by P1. Bottom will never be negative because price always increases. We look at an increase in price and how it changes. Again, where did the hundreds go? I don't do them because they're going to cancel out if there's one on the top and one on the bottom. The book likes to do them, so great. If you want to do them, fine. Mathematically, it's not going to matter. On your card, put one of these three, whichever is going to make the most sense of your brain. If you're a word person, you might want in words. If you want the shortened word version, put this one. If you just want the variables, put the variables. But put one of those formulas on the first section of your card. How about, sorry? P1. We never do with the price of 0 because we assume the supplier is going to want something for their product. So I'm with you, though, because you can't divide by 0. But yeah, we never do with P1 0. Mathematician. True, yeah, because then you're multiplying by 0. Okay, so whichever one of these your brain's going to like best, put that on your card. Then as we go through the unit, we do the other 3. Then on that card, we'll just have the 4 formulas all together so you don't have to keep flipping around the notes. So here's a typical question. It gives you all of the things you need to know. It's just a matter of sticking it into the formula. Price of butter went from $4 per pound to $5 per pound, and this caused a quantity demanded to drop from 400 pounds per week to 250 pounds per week. Calculate the price elasticity of demand. I'm a highlighter or a circler, so I like to just look at the key information. In the grand scheme of things right now, we don't care it's butter. We really just care the numbers, so we know the price went from 4 to 5. So there's our increase in price. Because of that, the demand dropped from 400 to 250. Is it always going to drop? So if you increase the price of something, think of your demand curve, what's going to happen to demand? But can it ever increase? No, because the demand curve goes down, right? That's why you're going to always have a negative on the top, and we need to balance out that negative. That's what the absolute value does. And we want the price elasticity of demand, so that reminds you it's PED. Again, it's all we know right now, but by the end of the unit, we're going to have 4 acronyms, 4 formulas. You need to keep in your mind what we're calculating. So quantity goes on top, and we're looking for the percentage change in the quantity demanded. So we take the new quantity, which is 250, minus the old quantity or the first quantity, 400. We want to know the percentage change, so we're dividing by the old. And then I'm going to put in brackets times 100, because again, mathematically, it's not going to matter if you do or not. Let's just do that first. Okay, so this would be a calculator question if you wanted to use a calculator. Offer 0.375. If you chose to times by 100, you'd have 37.5, negative 37.5. Confirmation. So confirmation means, yeah, I got the same number. So this is why we need either the negative or the absolute value. It's up to you, because this will always come out to be negative and we need to get rid of it. So you can either negative, negative. I just throw the absolute value around it because I'm a mathematician, can't help it. And negative 0.375 becomes 0.375. That's the top of the formula. Now we have to do the bottom of the formula, which is the same thing, but now for price. New price, old price, divided by old price. And again, I'll put the times 100. If you did it on the top, you have to do it on the bottom. If you left it out on the top, you leave it out on the bottom. You can't pick and choose. Offer of 0.25. Confirm. Nobody confirming. And then to calculate PED, we're just dividing those. Confirm 1.5. Hiroki confirmed it without a calculator. So for this example, we know that the price elasticity is 1.5. Of course, right now that means nothing to you. So here are three situations. You're either going to get a number bigger than 1, you're going to get a number between 0 and 1, or you're going to get a number that's exactly 1. We're never going to get a negative number for this. Other ones we're going to calculate, we will, but this one will never be negative. Why? Because we took the absolute value to get rid of the negative slope. Okay, so this will always be a positive value. So your choices are between 0 and 1, 1 exactly, or greater than 1. If you get a number greater than 1, what it means is that's an elastic response. That means it's not a rock, it's a rubber band. How stretchy is the rubber band? Well, that matters how big the number is. If you have 1.5 for butter and you have 3 for Coca-Cola, which one is more elastic? Coke is going to go first if you have to cut something out. So anything bigger than 1 means that it is elastic. That's rubber band. If it's between 0 and 1, that is called an inelastic response. That's the rock. How hard of a rock? So is it a soft rock that you can hit and it crumbles, or is it a boulder that's really, really hard? Well, that depends how close the number is to 0. If you have a 0.001 PED versus a 0.9 PED, is going to be a meteor, exactly. So the number is on the scale. If it's exactly 1, we call that a unit elastic response. Unit elastic response. So just putting that under number line for the left brains, this can go all the way up to infinity. In theory, you're never going to have one that's that big, but could go on forever. So for anywhere between 1 and infinity, this is elastic. I'm going to attempt to draw elastic. Kind of looks like a hula hoop. Just go with it. If you're between 0 and 1, that's inelastic. That's your rock. And if you're exactly on 1, that's called unit elastic, which we'll talk about in a second. What did you guys get for the Snickers example that we did? So this was the very first thing we calculated on Friday. Mm-hmm. 0.44, I think I remember that as well. What does that tell you in terms of Snickers for this very small market with a very limited budget and not a lot of things to buy? And we want our Snickers, right? We don't care if the price went up because we didn't have a lot of things. The way we calculated it, it's an inelastic commodity to us. It's going to vary from market to market. It's going to vary from people to people. For us, inelastic. We're eating our Snickers no matter what. Just two definitions from the book. If you get exactly 0, which in theory never happens, that's called perfectly inelastic. And if you get infinity, which again mathematically can never happen, that's called perfectly elastic. That's exactly why. They're saying a really, really, really big number because you can't get exactly infinity. Oh, economists versus mathematicians. So we're going to do a short partner activity. And I've given you a PED for a certain market. We don't know what it is, and I've given you the values. And just with a partner, I just want you to talk about these questions and just jot your thoughts down on scrap paper, and then we'll discuss as a group. Okay, so I'll give you about 10 minutes. I'll let you pick your own. So just want to talk about the table first before we get to the questions. And remember what PED is asking or calculating. PED is saying as price goes up, what is happening to the quantity demanded? That's what it's measuring, is what are people doing with their buying habits if the price of something increases. The closer the number is to 0 doesn't mean they're buying less. What it means is it's a smaller change. People aren't really reacting. Whatever was happening before is still happening now. That's your medicine, your insulin, for example. So just because they raise the price of insulin, no one's going to stop using insulin, right? So that's what a closer to 0 means. What does a number bigger than 1 mean? There's a change. So people are suddenly buying less, changing up somehow. So let's just look at the inelastic. So tell me salt, for example. What does that mean when we say the PED is 0.1? Very inelastic, which means people are still buying the same amount. Okay, it doesn't mean they're buying less. It just means they're still basically buying the same amount. Now remember, we don't know what market this is. We don't know where this is. And this is just a snippet of what's going on in the market. It's not that the only things they sell are green peas and cars and tomatoes, right, which seem like they have nothing in common. They've just pulled that just to kind of give you an idea. There is a clue in the table that tells you this is not Canada. Who can find it? No, we have private schools. SJR, St. Paul's, right? Is it something about housing? I'm not telling you. We don't have shellfish. I think BC and the East Coast definitely do. We in Manitoba, not so much. But we have 2 coasts that are pretty big. Coffee. We love coffee. Restaurant meals. High five to Derek. Say it again. What is a physician service? Oh, isn't that like a doctor? That's going to the doctor. And do we care if the price changes? And we always go, wait, but there's no price to going to the doctor. Oh, sure there is. We just don't pay it. Who pays it? The government does, but there's a price. Every time you see the doctor, they're billing the government for that. So that tells me it's not Canada because there's a change in the demand. We don't care if the price of the doctor goes up. It's probably also not a landlocked country because of all the fish that's in there. And being Manitoban, we tend to get introspective and we go, well, we don't eat a lot of fish. No, we don't. But countries that are surrounded completely by water do. Spain, that's the most popular meat, is fish. right? They don't have the land to breed cows the way we do. So there are always some hints on kind of where the market is. But in general, we don't know. We don't know where this is. We just know what these values mean. What does highly elastic mean? As prices going up, there's a big reaction from consumers. Which one is the largest? And that happens in Winnipeg in the winter. What happens to fresh vegetables in the winter? Well, the price goes up. Why? Because we don't grow them, we got to import them. And typically, if you think of your household, do you eat more fresh fruit and vegetables in the summer or in the winter? And which one do you eat more expensive vegetables? So apples are fairly cheap. You probably eat those all year round. Oranges are cheap. But when you get into more expensive fruits like cherries and peaches and mangoes, do you eat those in the summer or the winter? That's because they have a high elasticity to them. We're like, whoa, $8 for a mango? No, thank you. I don't know, made it up. What is unitary elastic? We call that a one-for-one elasticity or a one-to-one elasticity. It means for 1 unit change in price, there is a 1 unit change in demand. So you may just want to jot that down. We call it one-to-one. One-to-one elasticity. 1 unit change in price is a 1 unit change in demand. It is like a line. Oh, you're like already in tomorrow's lesson. Pause that. So which products are the most inelastic? Which one on the list is the most inelastic? So toothpicks, matches, and salt. Why is salt very inelastic? So you need to know a bit of history here and what we use salt for.
Boys, I got this one.
Okay.
Well, for the first part, there's like no substitute good for salt, and it is in almost every food that there is around. So you need salt.
Okay, who has salt and pepper in their kitchen or on their table? Right, pretty much every North American has salt somewhere around them, right? You go to a restaurant, there's salt and pepper on table. Why? Well, we like the taste of salt. Why do we like the taste of salt?
We're built that way.
Yes, because our ancestors did what with salt?
Ate it. Cooked with it. Preserved things.
Preserved things with it. Before refrigerators, salt was the only way to preserve things. So we are genetically produced now to like the taste of salt and to want salt. Does anybody or anyone in your family salt stuff before you eat it? I always do. In a restaurant, I can't help it. I just salt it before I even taste it. I know, because I'm just modified to love the salt. So salt, we say, is generally inelastic because it's in everything we eat. Typically, that's the first thing when you're cooking. You grab the salt and pepper if you watch cooking shows because of our ancestors and how they preserve things. Not every culture is like that. North America is definitely like that, but not everyone is. Why would the demand for toothpicks be inelastic? So as the price changes, people's buying habits with toothpicks are not changing. Yeah, so people need some way to clean their teeth, whether that's dental floss or toothpicks, which is the cheapest? What's cheaper, toothpicks or dental floss? Toothpicks really, really cheap. So that's one of the factors is the price of it. Okay, let's talk about short run, long run. So we did a little bit when I was answering questions. Is short run is price goes up today, what's happening tomorrow, the next day, in a week or so, maybe a month. Long run is 3-4 months down the road. So why would gas be different? So price goes up today. What does an elasticity of 0.2 mean?
Short or small change.
Small change, so not a lot happening. Connor, why?
Because tomorrow you still need gas, so you're going to buy it. But in 3 months, you're going to buy an EcoBoost engine or a hybrid, and you're just going to be like, screw gas out.
Well, let's say you're going to change your driving habits. So maybe you buy a new car, you trade it in for something that's better. Maybe you don't drive your car at all and you switch to buses or bikes. So in the short run, you can't probably go out tomorrow and trade in your car. You probably can't in a week go in and trade in your car. So in the short run, it's pretty inelastic because you need gas to drive. In the long run, you're probably going to end up changing your habits in terms of gas. Okay. Does that explain why short run is more inelastic than long run? Chevrolets. So why are they very elastic? So lots of, what's the vocabulary? Lots of substitutes, right? We've looked at that word before, lots of different substitutes. So generally, what is more expensive, Chevy or other brands? Chevy's typically a more expensive brand. Okay, so something about that is what you need to explain. Yeah. Some people are very diehard about not buying foreign cars. Some people like to buy local, and which is always funny in Canada because we don't have any local cars. But why would tires be unitary elastic while gasoline is inelastic? So they both have to do with your car. Why is tires more elastic than gases? Okay, so if you had very little money and the price of tires and gas went up, what are you going to spend your money on? You're going to put gas in your car before you're going to put tires. If you buy tires and can't afford gas, are you going anywhere? No, right? You need the gas. The tires eventually you're going to need to replace, but it's not as important. Yeah. People drive on bald tires all the time. Now again, if you compare winter in Manitoba versus summer in some other country, we might say winter tires are more inelastic than other kinds of tires, but that's just Manitoba. Okay, the activity you need to